Welcome in the third section of our course. In this section, we'll see how to avoid shuffle and reduce operational expense of our jobs. We'll be detecting a shuffle in a processing. Next, we'll be testing operations that cause shuffle in Apache Spark. So we'll see when we should be very careful and which operations we should avoid. Next, we'll see how to change design of jobs with wide dependencies. In the fourth video, we'll be using key-by operations to reduce shuffle. In the last video of this section, we'll see how to use custom partitioner to reduce shuffle of our data. And this is a first video in which we'll be detecting a shuffle in a processing. So we'll be loading randomly partitioned data. We'll see how that data is loaded and we'll try to guess where that data will be loaded. Next, we'll be issuing repartitioning using meaningful partition key. So we'll try to repartition data to the proper executors using deterministic and meaningful key. At the end, we'll try to explain our queries by using explain method and we'll be understanding the shuffle. So let's go to the code. So here we have a very simple test. We are just creating a data frame with some data. So we are creating an input record with some random UID and user 1. Then another input with random ID and user 1, and then last record for user 2. We are creating a data frame, and right now let's imagine that this data is loaded from the external data system. So it can be loaded from HDFS or from some database like Cassandra or NoSQL database. Once we loaded it, there is no predefined or meaningful partitioning of our data. So it means that the input record number 1 can end up in the executor first, and record number 2 can end up in the executor second. So even though that data is for exactly the same user, and it is very likely that we will be executing operations for the specific user. As we remember from the previous section, we used reduce by key method that was taking the user ID or specific ID and reduce all values for the specific key. So this is a very common operation. But with some random partitioning, we don't have that. So the good thing is to repartition that data using our meaningful key. So when we'll be using user ID, we will repartition it. So the result will be that every record that has the same user ID, so user 1, for example here, will end up on the same executor. So executor first will have all data for user ID. So if this is on the executor 1 and this is on the executor 2, after repartitioning, data from executor 2 will need to be sent to the executor 1 because this is parent, let's say, for this partition key. And this is a shuffle. So shuffle is caused often by loading data that is not meaningful partitioned or even not partitioned at all. Because still we need further in our processing to do operations on a specific key. So we should load that data partitioned, and if there is no possibility for that, we can repartition it further to incur that cost, but at the beginning of our chain. At the end, we are explaining query to see what is happening inside. So let's start it. We can see that our plan is that we are repartitioning by expression user ID, and this is logical plan. But when we are going to physical plan, it shows that it uses hash partitioning. So we will be hashing on the user ID value. It will be scan of the RDD, and all keys that have the same hash will be sent to the same executor. So we will achieve our goal.